Section 11.6, the ratio test. So we will quickly review the factorials. If you have seen them, it's good. If not, then there is a quick view. The factorial is defined, first thing, a factorial is defined for positive integers. If n is a positive integer, then n factorial will be equal to n times n minus 1 times n minus 2 times so on until we get 3 to 1. So what we are doing is we are starting with the number which is whose factorial we are calculating. So n is that number, and this exclamation mark is the symbol for factorial. This exclamation mark means factorial. Okay. So here are the examples. If you have 2 factorial, so you will start with 2, come down 1 value or 1 number. So we get 1. So when we get 1, we stop. So 2 factorial is nothing but just 2. Now 1 factorial is 1, and because it's 1, we have to stop. Now 0 factorial is something that is defined to be 1. So we define as 1. 0 factorial is not 0, but it is 1. So in the same way, 3 factorial will be 3 into 2 into 1, which comes out to be 6. 4 factorial is 4 into 3 into 2 into 1, small. 5 factorial, can see that. Now as we go up and up, the number goes up very quickly. There is 10 factorial, will be 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. All those numbers are multiplied together, give us this big number. So now notice here that we can also break down these like in different ways. Now 10 factorial, I can write it as 10 into, notice here that so we have 10 into 9 into 8 into 7 into 6, 5, 4, 3, 2, 1. So if you notice here, if I look at this one, this is 7 factorial. That means I can write 10 factorial as 10 into 9 into 8 into 7 factorial. So why would I want to write it like this? It may be like the requirement of the problem, so that we can in some cases do that. In the same way, we can also say 10 times 9 factorial. 10 times 9 factorial. Now note here, when things are written like this, 2 factorial and then 3 factorial, it means 2 factorial is 2, 3 factorial is 6, so 2 into 6 is 12. It is not 6 or 6 factorial, okay? It's not 6 factorial. In the same way, if you see like 5 into 4 factorial is not going to be 20 factorial, okay? It is going to be 5 into 4 factorial, which is 24, so we get 120. So just be careful with the factorial. So if we have a 2n factorial, so we will start with 2n, subtract 1, subtract 2, and so on until we get to 3, 2, and 1. So this is how the factorials work. Here is the example that I was just mentioning. 3 factorial into 4 factorial, so you have to separately write them as factorials and then expand them and then get the answer. Now, consider the following series now. 1 over n factorial. What does it look like? It is 1 over 0 factorial, because we are starting with 0, and 0 factorial is 1. 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial, and so on. So you will see that we get 1 plus 1. This is going to give us 1. This is 1. Then 2 factorial is 2, so 1 half. 3 factorial is 6, so 1 6. Plus 4 factorial is 24, so 124. and then so on. Now this special series is actually E equal to E. What is E? Remember, it is the number like 2.718, and actually there are no digits here. So now that we have a review of the factorials, let's look what the ratio test tells us. It says compute the following limit. So it's asking you to take two terms, consecutive terms of the series that you are looking at, and take the ratio of the two terms with the later term on the top and the previous term at the bottom. So an plus 1 over an, and absolute values of that, and n equals to infinity. Now if the limit is L, and if L is less than 1, we say series converges absolutely. If L is greater than 1, series diverges. And if L is equal to 1, the test is inconclusive. You have to apply use some other test. The ratio test won't work. So let's look at the example. First example here. So it says a summation negative 1 to n, 3 n over n factorial. I don't know why this 1 is in here, just by typo. Okay, so what is a n here? If you notice, a n will be negative 1 to the n plus, oh no, I see. This is the power of negative 1. So this is what we have. A n is equal to negative 1 to the n plus 1 e raised to n over n factorial. This is our a n. If we write a n plus 1, n plus 1 will be equal to negative 1 raised to the n plus 2 times e raised to n plus 1 over n plus 1 factorial. Now we have to find the ratio a n plus 1 over a n, and absolute values would give me negative 1 raised to n plus 2, 3 raised to n plus 1 divided by n plus 1 factorial divided by a n, which means multiplied by reciprocal of a n. So it will be n factorial goes up, negative 1 raised to n plus 1 goes down, and then 3 raised to n. Now this negative, you look at the power, this power is the top power at the top is 1 more than this. It means we are left with 1 negative 1 at the top. So we are left with a 3 here, and then we have n factorial divided by n plus 1 factorial. Now what the absolute does, it gets rid of this negative sign. So we have just 3 into n factorial over n plus 1 factorial. Now n plus 1 factorial is bigger than n factorial, so I will break it to like n plus 1 times n factorial. N factorial cancel out. We are left with 3 over n plus 1. Now we take the limit. So this goes to 0 as n goes to infinity. Now 0 is a number which is less than 1, so it converges absolutely. Another example. So here an is n pi raised to the power n over negative 3 raised to n minus 1. And an plus 1 will be n plus 1 pi raised to n plus 1 all divided by negative, okay, I can subtract negative 1 raised to n and 3 raised to n minus 1 plus 1 plus n. So now an plus 1 over an absolute is equal to n plus 1 times pi n raised to n plus 1 whole divided by negative 1 raised to the power n and 3 raised to the power n times the reciprocal of the an, which will be negative 1 to the n minus 1, 3 to the n minus 1 over n pi n, which is equal to, now note here the negative, this is smaller, so we are left with a negative sign at the bottom. What happens with the rest of the term? Okay, we will have an n plus 1 at the top and then n at the bottom. What happens to the 3? This is 3 to the n 3. So there is a 3 at just a single 3 here, and there will be a pi left in the top. Now the negative 1 will go away, so we are left with pi over 3 times n plus 1 over n, which is going to give us pi over 3. We can write it 1 plus 1 over n. We can pull the pi over 3 outside. So it's fine. And then gives us pi over 3 into 1. And this gives us pi over 3, then and goes to infinity. So now what is pi over 3? Remember the pi is 3.14, and when we divide it by 3, we get a number which is greater than 1. So series diverges.